Today's topic is discrete distributions. So let's start with a couple of definitions. Let's go with what a random variable is. As we've seen before, a random variable is simply a variable that is random. No, it deals when we're doing some sort of chance experiment. We just give it the title of random variable. Now, in looking at random variables, we have two main types. We have discrete and continuous, and so this particular unit is about discrete variables. The next chapter we'll get into continuous distributions. And just to remind you what makes discrete discrete, it is a count of some kind. So I can have one house, two house, three houses. I can't have 2.5 houses. That's the lack of decimal. Although the counterexample we looked at earlier in the class, money, we only have two decimal places of accuracy, but time, we can have as many decimal digits as we want. So time would be considered a continuous variable, whereas money is considered discrete. Okay, I'm getting ahead of myself here. All right, so we're going to look at that. Some characteristics that make a discrete distribution special. We give a probability associated with each event that can occur. So in my silly example of houses, the probability of having one house versus the probability of having two houses versus three. So each event has a unique probability associated with it. And typically we communicate this through some sort of table or histogram, or occasionally you get some equation that you can use to calculate the missing information. Within a discrete distribution, every probability has to be between 0 and 1. This goes back to I can't really have 150% chance of rain. Anytime you talk about probabilities, it's got to be between 0 and 100%. So the p-values we limit between 0 and 1. And if I've, in a discrete distribution, if I've got everything within the sample space, then the probability should add up to 1. So I should be able to add everything, whatever the decimals are, should get a sum of 1 there. Okay, so we're going to go through an experiment here. You don't have to really get 3 coins. We're just going to think through what one might expect to see. So suppose we toss 3 coins and record the number of heads. What would our random variable be defined as? Well, you got to think about what are we interested in. If we're tossing coins and we're writing down the number of heads, then what we want to see is the number of heads. Okay, so I'm going to go to a Word document to write out the probability distribution of this. Again, probability distribution is what does one expect to see. So let me go do that. Okay, so let's kind of think about what might happen. As I toss coins, I could see 0 heads, I could see 1 head, I could see 2 head, or I could see 3 heads. So let me get one more column here. I could see 3 head out of the coins. Okay. So let's kind of think about the various ways that this could happen. So if I have 0 heads, that could be, that's only one way, tail, tail, tail. If I've got 1 head, that would be either a head, tail, tail, or tail, tail, head, tail, or would be, let's see, tail, tail, and then head. And there's a reason why I'm doing it this way. If I've got 2 heads is the same as saying 1 tail, so I can do the same 3-letter pattern, but switch the T's and the H's position. So that's one way I could have it. I could have that way, or I could have that way. So all the different ways I could have 2 heads. Or I could just have 3 heads. This would be the third case. Well, how many different ways did I just come up with? I had 1, 2, 3, 4, 5, 6, 7, 8 different ways. So the probability of 0 is 1/8. And let me get a, yeah. Okay, so 1/8 or 0.125. The number of ways I get three heads, I'm sorry, one head out of the three coin tosses is 3 out of 8. Okay, the number of ways I get two heads to show up is also 3 out of 8. So I can do that. And the number of ways I get all three of them to be head is 1 out of 8. Okay, and so there is our probability distribution for this particular setup. Now to draw a histogram, we're going to go to our calculator, and let's go ahead and turn it on and go to our stat list, and we're going to input both these sets of numbers. This is a different way to create a histogram. We haven't had this happen yet, at least in our note examples. So I'm going to just enter in the 0, the 1, the 2, and the 3, and then I'm going to type in the decimal, the percent of the time that this particular thing would show up. Okay. Okay, so from here we're going to go to stat plot, and we're going to make sure your plots are on, and then we're just going to highlight the histogram choice. Now this is where we're going to do something different. Remember, we've got two sets of numbers. Right now the calculator is just going to go to list 1, but we have those frequencies that we typed in there about how often something shows up. So I just need to tell the calculator to go for its frequency, go to where we typed it. So we typed it into list 2, so I'm going to tell it to go there. I'm going to try that again. Okay, try it one more time. There we go. Okay, finally got it to do it. Okay, so then normally from here we go to zoom stat, so zoom 9, and oh my, that does not look right at all. Normally we have several rectangles. So let's go to window and let's kind of troubleshoot this and see what settings might have happened, and hopefully yours looks like mine. If it worked perfectly fine, that's okay too. Just sit tight for a second. So if we go to window, let's kind of take a look at what it's doing. It is telling me that it's going from 0 to 6 and it's counting by threes. Okay, I know the numbers go from 0 to 3 and I want it to count by ones. So I'm actually going to have it go back 1 to -1, and we'll have it go up to 4 because I'd like to see everything. And that looked fine. I didn't really see an issue with that. So with the Y's, having it go up to 1 is fine. So I hit graph again, and I get this lovely histogram. Okay, so then I'm going to, one thing we can do is we can hit trace, and it will go through each value. It says here that from 0 to 1 you had a probability of 0.125, and then from 1 to 2 it's 0.375. So you can kind of see the frequencies. It's basically the same numbers we typed in. And now that we know about things like symmetry and bell curve, we can describe this as a nice pretty bell curve. Okay, moving on with a different example. We've got we're going to pretend that this data represents whether or not the number of classes a student has registered for. And we can see that we're kind of missing a number. And that's the first question they ask us is what percent is taken for classes? Well, in this case, we have to kind of think back to the rules dealing with probability. We're claiming this is all the possibilities. So what do we know has got to be true about these particular numbers? All of them have to add up to 1. So if I take out my calculator, and let's go to the home screen here, and I just add up all these decimals that I do see, and let's see what we add them up to. Oops. Let's see, 0.16 plus 0.05. Okay, so then I hit enter and I get 0.93. Okay, so what's missing? That would be the 1 minus 0.93. So I can just, I know it's 0.07, but some people need to see that. Anyways, so we got 0.07 for the missing number. Sorry, let's try that again. I took a look at my answer key here and I realized I mistyped in. It should be 0.02 plus 0.03 plus 0.09 plus 0.4 plus 0.16 plus 0.05. All right, let's see if that works out better. Okay, and then I want to subtract that. Okay, that works better. Should be 0.25. Okay, so lesson here is just be careful when you're doing an online calculator is what the lesson is. Okay, so let me get that answer copied over. Okay, the next question is what is the probability of something being less than 4? So what's the likelihood that a particular student is taking less than 4 classes? Well, in a discrete distribution, don't go away calculator, if I'm less than 4, what numbers do I actually care about? Well, in this case, I care about anything less than 4, which is 1, 2, and 3. So I want to take the corresponding probabilities of those numbers. So 0.02 plus 0.03 plus 0.09, and the sum of that, so 0.14, would be the probability of less than 4. Okay, and then the last question is, what about if it's less than or equal to 4? Okay, so the only difference here is now I want to include 4 with that number. So I want to take that 0.14, which we just found, and add to it the 0.25, and that gives us 0.39. So 39% of the students are taking 4 or less classes. Okay, now the last little question right there at the bottom says, what's the probability that a student is registered for at least 5 courses? Okay, so that phrase "at least" is one of our buzzwords. Easier way to do at least is switch it to 1 minus 1 less than it. So if I want at least 4, that's the same as 1 minus 4 or less classes. Since I just figured out that the 4 or less would be 0.39, so to get 5, at least 5, it's 1 minus the 0.39, which is 61%. So I know that 61% of the students are taking at least 5 courses. Now the other way to do this question is I can go up here. If I want at least 5, that means I want 5, 6, or 7. So I could have just added up those numbers to get the same answer. But we have this nice easy shortcut for at least. So there you go.